From two Sydney students fixing an instrument on the James Webb Space Telescope to a global analogue space mission and new theories about the location of Martian ice, this is a wrap of the past 5 Talkin Science Daily Bites. A pair of Sydney PhD students helped sharpen the view of humanity's most powerful space observatory without leaving Earth. As an indelible reminder of this thrilling result, the students, one of whom is now a postdoctoral researcher at Leiden in the Netherlands, had tattoos of the instrument their work has repaired inked on their arms. This remarkable technical breakthrough saw the development of a software fix that corrected blurring in images made by NASA's multi-billion-dollar James Webb Space Telescope, restoring crisp performance to one of its vital scientific instruments, all without the need for a space mission or astronaut repair like Hubble. The achievement builds on the only piece of Australian-designed hardware on the JWST, the aperture masking interferometer, created by Professor Peter Tuthill from the University of Sydney's School of Physics and Sydney Institute for Astronomy. The AMI lets astronomers take ultra-high-resolution images of stars and exoplanets by combining the light from multiple patches on the telescope's main mirror, a technique known as interferometry. However, after JWST began operations, scientists discovered that AMI's performance was being degraded by subtle electronic distortions in its infrared camera detector. These were injecting fuzziness into recovered images, a problem reminiscent of the telescope's predecessor, Hubble Space Telescope, as I said. That early blurry vision after launch had famously required a space shuttle mission and astronaut spacewalks to correct. Rather than designing a new lens or mounting such a costly rescue mission, the PhD students from Professor Tuthill's group, also working with Associate Professor Ben Pope at Macquarie University, created a data-driven, software-only calibration system that fixed the focus from the ground. US scientists have used computer simulations to figure out the best personalities to send on long space missions, like a 3-year trip to Mars. They say including a diversity of personalities may make for a more resilient team when faced with the stress and isolation of such a long mission. The team fed their simulations data about personality types and psychological theories, investigating how 5 personality traits, openness, conscientiousness, neuroticism, extroversion and agreeableness, affect the various mission roles and skills and their impact on the stress, health, performance and cohesion of the team. They found teams with a variety of personality types performed better than those in which they were all the same, and say a mix of coping styles and interpersonal dynamics might help teams maintain stability over time. Although the simulations didn't take any changes to personality types during the mission into account. The researchers say the results may help inform future crew design strategies for long-duration space missions. A discovery of binary stars could be the first step in building a more complete picture of how our galaxy formed, according to astronomers from the Australian National University. The discovery is part of an ambitious 10-year program to scan the entire southern sky every few nights. The study's lead author, ANU researcher Dr. Giacomo Cordoni, said the Legacy Survey of Space and Time, or LSST, will build an extraordinary movie of the universe. This survey, run from the Vera C. Rubin Observatory in Chile, will allow us to track billions of stars and galaxies as they change over time. It's designed to unravel the history of star clusters, galaxies, and the Milky Way itself, Dr. Cordoni said. Using Rubin's first public data set, Data Preview 1, ANU astronomers detected binary stars across the outer regions of 47 Tucanae for the first time. They found that the frequency of binaries in the outskirts of the cluster is about 3 times higher than in the dense central regions, which had previously been studied with the Hubble Space Telescope. The results suggest that while binaries are gradually destroyed or disrupted in the crowded centre, those living in the quieter outskirts, the suburbs, if you will, can survive. preserving something closer to the cluster's original population. The discovery is a crucial new piece of the puzzle of how globular clusters, some of the Milky Way's oldest inhabitants, formed and evolved. A 2-week simulated space mission, the only one of its kind in Australia, to join concurrent missions around the world, put a crew through their paces while performing space experiments at the University of Adelaide. The university and international space testing research and development startup ICEE.Space joined forces for the ADAMA analogue astronaut mission in Adelaide, Australia, last month. 4 analogue astronauts crewed the mission in a controlled environment, and the university's extraterrestrial environmental simulation covered regolith analogue terrain for experimental research facility. It's got to be an acronym in that, located at the Roseworthy campus. During the mission, the astronauts tested sustainable mission systems, next generation analogue spacesuits and habitats, as well as performing lunar mission simulations and operational research, which will help build a better understanding of how astronauts cope with living in space. Knowledge gleaned from the ADAMA mission will be used to inform future deep space exploration. Explosive volcanic eruptions on Mars may have transported water to equatorial regions where it froze into thick ice, according to computer simulations of the red planet's ancient history by US and Italian researchers. The authors suggest these eruptions may also have led to conditions that allowed these ice deposits to continue to exist under the surface today, and the findings could be useful in identifying potential sites for exploration in future crewed missions. We had thought most of Mars's ice was at its poles, but recent measurements have suggested there is also ice nearer the planet's equator, leading scientists to ponder how it got there. The simulations suggest volcanic eruptions may explain this, releasing steam that then froze in the frosty Martian atmosphere around the equator. If this ice was buried under volcanic debris, it could still be there today, the simulations suggest. The conditions predicted by these models in the event of multiple volcanic eruptions over time could help explain the detections of elevated near-surface hydrogen in equatorial regions, with implications for human exploration of the red planet. Daily science and space stories with an Aussie flair, plus a deep dive into the science or space headline of the week, and the occasional science fiction podcast. Got to do some more of those. Like, follow and subscribe for more. Membership available to help us do more. That's at the Trek.Zone/support. This is Trekzone's Talkin Science.